Okay, we begin with problem number 9. We want to find the particular solution. Again, we have an initial condition that says that y of 0 is 3. That means it passes through the point 0, 3. And it says that dy over dx is equal to xy over 2. So I'm going to use separation of variables. I'm going to use dy is equal to xy dx over 2. So how do I get the y on the other side? Divide by y. So we have 1 over y dy is equal to x over 2 dx. Now what? Integrate. What's the antiderivative of 1 over y? Natural log of y is equal to x squared over 4 plus a constant. So the key now is to determine what that constant is. How do I determine what the constant is? I solve. So I use 0 for x and I use 3 for y. So I have the natural log of 3 is equal to c, because x is 0. 3 is positive, so the absolute value doesn't really matter in this situation. But you can see that if you would have come up with, say, negative 3, then you would turn that to positive. So make sure it's in the domain. So I now have the natural log of y is equal to x squared over 4 plus the natural log of 3. If it says to solve, I create a base of e. In this situation, I'm going to solve for y. Create a base of e. And I have, that goes away. I have y is equal to e to the x squared over 4. I'm not going to write plus natural log of 3. What am I going to write instead? Times e to the natural log of 3. Yep, so e to the natural log of 3, e and natural log are inverse operations of one another. So therefore, we get y is equal to 3e to the x squared over 4. So what I did is I took the properties of exponents. For example, e to the 7th is the same as e to the 5th plus 2, right? Which is the same as e to the 5th times e to the 2, because so I just separated it like that. Better? Okay, let's try our next problem. Let's look at number 10. dy over dx is 3x squared over 2 e to the 2y. Y of 0 is equal to 1/2. I know it passes through the point of 0, 1/2. I'm going to cross multiply e to the 2y dy is equal to 3x squared dx. What's the antiderivative of 3x squared? If you had a plus c on the other side, you would just combine your constants, and you would end up with just one constant anyway. Antiderivative e to the 2y. 1/2 e to the 2y. So for those of you who don't see that, u is equal to 2y, so du is equal to 2 dy. I don't have a 2 dy, so I multiply by 1/2. 1/2 du is equal to dy. So 1/2 integral of e to the u du would just be 1/2 e to the 2y. Okay, let's solve for our constant. It says that it passes through the point 0, 1/2. So that means that I place 0 in right here. I place 1/2 in right there. So I end up with c on the right side. On the left side, I end up with 1/2 e, or e over 2. So I have 1/2 e to the 2y is equal to x cubed plus e over 2. What to do, what to do. Multiply through by 2, e to the 2y is equal to 2x cubed plus e. Then, natural log of both sides. 2y equals natural log of 2x cubed plus e. Why do I have to include the absolute values? Divide by 2, y is equal to the natural log of 2x cubed plus e. Oh, I didn't do that very well. Y is equal to the natural log of 2x cubed plus e, that entire piece divided by 2. So I believe that the last 3 problems that we did were all AP problems from previous years. I have not yet checked the answer keys, but I'm confident that we're correct. I don't know. I just found a site that said the year. I'm guessing that they were in context of a free response. Okay, flip it over. So now we're going to do something that looks challenging, but is actually quite easy. So Caleb had the thought of the day yesterday when he talked about doing the box game here. So that's what we don't do. But the easiest way to think about this is these are slope fields, and I want to be clear that I never, the first time I ever encountered slope fields when I started to review for the AP exam. So this is not, it's not as though you guys have to really understand that some of the things you're learning for the AP exam, they're cool, they're neat, they're fine. They don't have longevity in terms of mathematics. Okay? It's not as though, you know, if you guys saw these problems on the AP exam right now, you'd be like, I don't know what I'm doing. It's going to take us 15 minutes to figure it out. They just throw in certain things like that to kind of define themselves. And so they have. Good for you, AP. Well, you'd never use it. I mean, come on. Oh. Cult. All right, here we go. So what I'm going to do is this says the derivative is equal to x plus 1. And so what that means is if I have an x value and I have a y value, then the slope is equal to x plus 1. So I'm going to make a 3-tiered chart here. Yes, if you take a differential equations course, you'll see a little bit of this someday. Okay, that's it. All right, so I've got x. What do I place in for? So I'm going to pick a point. Sean, give me a point. A point. Great. So 0, 0. All right. So that's my coordinate. I have a coordinate. Now I will use the point 0, 0 to determine the slope. Well, it says the slope is equal to x plus 1. So it's 1. Give me another point. I need an x value and a y value, folks. Okay, 0, 2. So the slope will be 1. 5, 3. 6. Kelsey said 2, 3. So if x was 2, then the slope would be 3. So here's what they want us to do. They want us to draw segments through the point that match the slope. So at 0, 0, I draw a small segment that has a slope of 1. Through the point 0, 2, I draw a small segment that has a slope of 1. At 5, 3, which doesn't fit on here, I draw a slope of 6. At 2, 3, I draw a slope of, doesn't fit on here either, but I would draw a slope of 3. So let's start to figure this out a little bit, okay? I take the x value and I add 1. On the y-axis, what is the x value? 0, so the slope is, so I can draw 1 for a slope all through these points. Now, your question may be, how exact do your slope values have to be? Well, they should tell that they're positive, and they should know that it's bigger than a half. You know, you should be able to tell that you're trying to draw it at about a 45-degree angle. Okay, what is my x value here? -1. So if the x value is -1 here, what's the slope? So on the AP exam, they may not, like here I have, let's see, I have 1, 2, 3, 1, 2, 3, 4. So I've got about 12 here. So there's about, 40 dots on this grid. And they're not going to give you 40, but they might give you, say, 10. And if they give you 10, make the chart so you can see, they can see the work that you're doing. Okay. All right. So I've got -1 here. I'm sorry. Yep, the x value is -2, so therefore I get -1, so I have a slope of -1, just like this. Anyway, what's the slope going to be right here? Why? Because the x value is 1, and 1 plus 1 is 2. I do my best to draw a slope of 2. How about as I move to the right? Then it's going to go to 3, so I'm just going to try to make it a little bit steeper, and then 4. Kind of getting carried away. So I back up, this would be -2. And so there's our slope field. What? No. No. They're looking for reasons to give you points in this location, okay? They need to see that you have your 0. They're going to want, 0 should be right on, right? And, positive and negative at that point is really what they're looking for, okay? So, all right, now, I'm going to try to connect what we're doing right now with what we just did. If I cross multiply here, I get dy is equal to x plus 1 dx, and I take the antiderivative, I get y is equal to, what's the antiderivative of x plus 1? X squared over 2 plus x plus some constant, right? Suppose that the initial condition is going to be 0, -2. I'm sorry, -1, -2. What that means is that it starts at the point, or it passes through the point 0 or -1, -2. Now, if you look, what shape does the actual equation make? Makes a parabola, right? Well, if you would just kind of follow along the path of this curve, you can see that? Okay, what I'd like you to do now is I'd like you to do number 2 on your own. Go ahead. You don't have to draw it. You just try to draw the slope field. Just draw the slope field. Okay, do number 2 on your own. Draw a slope field. All right, I give you guys a couple minutes here. I'm not going to do the entire graph, but I will start with the 2y and start with values of 0. So where's y equal to 0? On the x-axis, correct? So that's the first thing I'm looking for, is to make sure you have zeros across there. And then for your y values, okay, so here I have a y value of -1, so I should have a slope of -2, -4, +2, +1. Okay, let's just do a couple other pieces here. Let's do x plus y. Somebody give me what's an easy way to start sketching x plus y? 0, 0, 0. 0, 1 would be 1, and then 2, then -1, -2. And I could do that same in the direction to the right and to the left, correct? So I've got 1, I've got 2, I've got 3, -1, -2, -3. And the other ones you kind of have to piece together. But one thing I recognize is that if x and y were opposite values, then you would get 0, say 1 and -1. So you can see here I have a coordinate of -1, 1, or I have a coordinate of 1, -1. And in both those cases, I get 0. Okay? Tell me, what should the slope fields look like in the first quadrant? They should all be, and in the third quadrant, they should all be negative. So you can kind of see what's happening here, with your picture. 1, 1 would be 2, 3, 3, 4, 4, 5, so on and so forth. So, get the idea? We don't need to spend a lot of time. I'm trusting you guys can fill this out once we get to the AP exam. Let's look at number 6. 6 would be, cause a little bit more of a concern for people. And so I'll make sure that we actually set up an XY chart here. And then our slope is -y divided by x. So tell me, what do you need to be careful of in this situation? 0 for what? What about 0 for x? It'll be undefined. So anywhere where x is 0, you would not have a slope field. So I'm just going to put little dots there so I know not to actually mark a slope at that spot. How about when y is equal to 0? Yeah, where is y equal to 0? On the x-axis. So I have 0 values right here. Okay. So that kind of outlines a little bit of my work. And now you can just start picking values. Let's do a couple. We'll do 1, 1. We'll do 1, 2. We'll do 2, 1, and we'll do 2, 2. Okay. So we'll do some values in the first quadrant. So what would the first slope value be? Second slope value? -2. Third one? 1/2 and -1. So you can see at 1, 1 I have -1. 1, 2, -2. -1/2. -1. True or false? All the values in the first quadrant will be negative. All the values in the second quadrant will be negative. False, they'll be positive, right? So you can kind of just think through those pieces. And that's the type of thing we want to go through when we accomplish these types of problems. So what we're going to do when you guys get back from lunch here, we're going to break here in just about 30 seconds. So you guys are going to actually match A, B, C, and D with problems 7, 8, 9, and 10. And then you're going to do A, B, C, and D with problems 11 through 14. And we'll finish up our work on slope field. We'll actually get to some free response questions. And so as you see here, we have 1 is sine of x, 1 is x minus y, 1 is 2 minus y, and 1 is x. If I were to start here, I'd start with x. And the reason why is I'd look at it and say, well, if x is 0, then the slope would be 0. And so x is 0 along the y-axis. So it could be this one, and it could be this one. Well, as I look at this one, this is obvious to me that this is a sine or cosine graph. So I'm going to match C with 7. That will leave B over here with 10. Second of all, as I look at number 9, what I really like is if I put in a value of 2 for y, what is the slope? 0. So I'm looking at a y value of 2, slope of 0, and A satisfies that. And then x minus y, if they have the same values, then it's going to be 0. And so 1 minus 1 is 0. And so if you look here, 1 minus 1, -1 minus -1, 2 minus 2, so on and so forth, D is going to go right there. So you don't have to plot out every slope, but you should be able to look through and say, well, I think that slope field matches. So real quick, try on your own the next set of 4, see what you get. We've got x plus y. I'm going to look at that one first. So I look at x plus y. If they're, positive, first quadrant should be positive. All of them should be positive. So that would leave this one as an option or this one as an option. If I look at the third quadrant, they should all be negative. That would leave both of these still as options, okay? So I'm going to try looking at maybe something else. If I have a value of 0, 1, the slope should be 1. Still looks like this is good, doesn't it? So how do we decide between those two? Well, let's look at a value that's different. Let's look at the point 0 or negative 1, 0. So negative 1, 0, should the slope be positive or negative? The slope should be negative. And so therefore, A is the correct matching here. Okay? If you look here, the y value is equal to 0 along the x-axis, and there's no slope. Which one would have no slope? 13. So D is 13. If you've got a 0 value for y, then it would be undefined. So you can see that you have no slope on those spots. Okay, 1/2 y. 1/2 y. So that means if you have y equal to 0, which would be the x-axis, then you should be at 0. And looks like we have C right here. Our last one would be B. And again, if you put in a x value of 0, you would have a slope of negative 1. And all these at an x value of 0 have a slope of negative 1. So, okay, all right. Flip it then to, we're going to do one AP problem today. Before you complain, realize that you do not have class tomorrow. And you simply have one problem to practice on your own. You won't, and that's the wonderful thing. You are tired of me by this time of year, and I understand. Okay, we're going to do problem number 6 from 2014. This is a great example. This is a free response question. It's a no calculator question. This was probably the easiest differential equation slope field type problem I could come up with. It says consider this differential equation dy is 3 minus y cosine of x. Let y equal f of x be the particular solution of the differential equation. Initial condition f of 0 is equal to 1. So I know it goes through 0, 1. Okay, and it says a portion of the slope field is given below. Sketch the solution curve. So this is not an exact science, but first what you must do is plot what point. And then you would kind of follow the curve the rest of the way. And so I would probably try to do something like this. You think that reasonably fits? I will show you examples that would be incorrect. The red line is obviously incorrect. Okay? The red parabola is obviously incorrect. That is obviously incorrect. No hand turkey, no gobbles. Okay, don't do that. All right. So I would think it's pretty fair to say that you should be able to get that point on the AP exam. Okay, good question. So Maddie's question is this. What if she drew it something like this? They're going to give you the points. They want the general shape. Okay? Part B is extremely simple as well. It says write an equation. As soon as I hear that, what do I write down? Slope and point on the line. What is my point on my line? 0, 1. So how do I determine slope? Rise over run. In calculus, we look for the derivative. Do we have a derivative? Yes, dy over dx is the derivative. This is the derivative right here. The slope field tells us the derivative. This equation tells us the derivative. So we have 3 minus y cosine of x. What do we plug in for y? What do we plug in for cosine, or for x? 3 minus 1. What's the cosine of 0? So we get 2. So this is a y-intercept because the x value is 0, so we have y is equal to 2x plus 1. And it says use the equation to approximate a linear approximation of f of 0.2. So f of 0.2 is approximately, what would I do? Let's plug it in. 2 times 0.2 plus 1. So f of 0.2 is approximately 1.4. Okay. And we finish with part C. Part C says we have a differential equation. Find the particular solution given it passes through the point 0, 1. This is where I use my separation of variables. You tell me what to do based off what we've learned. Okay, dy is equal to 3 minus y cosine of x dx. 1 over 3 minus y dy is equal to cosine of x dx. Integral. Antiderivative cosine of x. Positive sine of x plus c. Oh no, 1 over 3 minus y. Negative 1 dy. I do not have a negative dy, I have a positive dy. Negative du is equal to dy. What's the antiderivative of 1 over u? So negative natural log of the absolute value, 3 minus y. That's the antiderivative. I have a c. I'm going to now solve for the constant. What do I plug in for x? 0. So I get c is on the right-hand side. On the left-hand side, what do I plug in for y? 1. And so I get negative natural log of 2. That's what c is. Are we all okay with that? So now we have negative natural log of the absolute value of 3 minus y is equal to sine of x minus the natural log of 2. Okay. One of my students just committed heresy. Decided to cross off the natural logs. What do you want to do? Yep. flip signs, multiply through by a negative. Now I create a base of e. Those are inverse operations. Do you remember when we were in pre-calculus together? First semester college algebra last year, and we would do this type of stuff, and you get kind of angry about it. Some of you said, I hate natural log, okay? You still do? I mean, it's quite useful. Jeez. So I'll write this as, I'm not going to write this all out. What is e? What is I'm going to write as e to the natural log of 2 divided by e to the sine of x. Very good. So Maddie sees that e to the natural log of 2, those are inverse operations, so we get 2. Because it's negative, yep. So 3 minus y is equal to 2 over e to the sine of x. Subtract 3. Negative y is equal to 2 over e to the sine of x. Oh. Minus 3. That, my friends, is the answer. Adam drew a big hand turkey on his sheet. Everybody, put his little cranium between your fingers and squash his little head. All right. Here's what I would like you to do, folks. For tomorrow, or Thursday, because tomorrow I will not see you. Some of you will be at B&B. Some of you will be sleeping in. I can't. I'm required to be here to proctor the ACT. I don't know. So, here's what you have. I would like you to make an attempt. Now, or you can do it here. This is not homework. I'll give you 2 problems for homework on Thursday, but I want to be clear. You have no class tomorrow. Therefore, I would expect that everybody is able to give this a valiant effort. Remember, this is an exchange. I am asking for a valiant effort in exchange for no homework. You realize how little homework we're giving during this time, right? So your appreciation to that will be to do what you're supposed to do. Okay?